Hello, welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're an online and in-person meetup group. We haven't been doing many in-person sessions recently due to lack of presenters, but help online. We're hoping to get people, help them get into using Python and also introducing them to machine learning. The first week of every month we try to cater for absolute beginners, people who've never seen Python before, and so that's what we'll be doing right now. We're going to be looking at lists and dictionaries, which are two really useful data types in Python, but taking it from scratch. So hopefully you can follow along. This is our meetup page, and you'll see in the meetup page there's a link here to the Google Colab notebook, Jupyter notebook, which lets you run Python without even needing to have Python installed on your computer. That link should also be below the video that you're watching right now. So let's click on the link, and you want to open that in a new window if you're watching the video so that you can have them side by side. And this will open up the Colab notebook that I've created earlier. But you see it says changes will not be saved, and that's because I wrote it, not you. So what you can do is you can just click on copy to drive. You'll get a copy of it, and then you can make as many changes as you like and use it and come back to it later and see any notes that you've made in the notebook. So I'm going to do that as well. Private outputs, so I can hide that message. All right, so Google are giving us a virtual private server to run here, so I'm just going to click on connect to start that server up. It'll do it automatically. If you don't do it, it just takes a bit of time. And a notebook is made up of cells, and the cell can contain either text, which you'll see here, that's just some formatted text, and so is that, or you've got these grey cells down lower which has got Python code in them, and they're all color coded. So today our objectives are how to use this Jupyter notebook, which has got it running a type of Python called interactive Python, which you'll sometimes see described as IPython. So the normal Python that you'd use if you are running scripts or a Python program on a computer would be CPython, because it's the Python programming language written in the language C, and so you don't have to know any C, you just have to know the Python to get it to work. But they've got this interactive version, which is also fantastic for data scientists, because they can get intermediate results, and then they can design what they need to do next based on it. Or it's great for people learning, because they can get such a quick response. They learn the programming language quickly, because they can see exactly what each line is doing. And so as we go through these steps, I'll give you opportunities to type in your own Python code and try running it and seeing what it does. We're going to be looking at these data types: the list, the tuple, and the dict, and we're also going to be looking at how to write scripts in Python, and some of the programming structures like conditionals and loops. Here's a link to this notebook. Of course, you know where that is, the YouTube video, and the meetup event, but also this, which is really useful, which is our GitHub site, and there you'll see all our other events that we've had, and you can look through the topics there and look up past ones if you want to watch the video retrospectively of some of the other topics that we've got. We'll also be listening on Slack, so during this session you can ask questions on Slack. There are instructions below the video on how to get invitation to that, and we'll go in the Learning to Codes channel, which is part of Beginners Python, which is the name of our Slack group. You can also put questions into our the YouTube chat, which is beside the video, and I'll try to keep an eye on those as we're going through. So a quick introduction to Google Colab. You can type into a cell, you can press Shift Enter to execute the cell, and then the cells can be Python code or Markdown text. This is a Markdown text, this is Python code here. You can use question mark for the help menu for help. So to do that, like you create a new code cell. See here, I'm hovering between two cells, and it lets me insert a new code cell. And in there I could type a question mark, and then I press this play button or Shift Enter or Control Enter, and it gives me help on IPython that comes over here on the right. So Control Enter leaves you in the same cell when you're finished. Shift Enter will take you down to the next cell after you've finished. And if you want to look at all the different keyboard shortcuts, go have a look at this menu item here in Tools on Keyboard Shortcuts to how to use Google Colab. And so here we're going to start out with our very first bit of Python code, and it's going to be a list. And so we're going to put some data values, and I've got 7 data values here, 65432110, all in different data types. So the ones with quotes around them are strings. This number here is an integer. This one here is floating point because it's got a decimal point in it. This number here is it's a digit, but it's in a quotation mark, so it's treated as a string, and then just a few more strings. Now I'm going to store this list into a variable. The variable could be called pretty much anything I want. And I'm going to call it LST because it's going to be storing a list. Now, just a word for the newcomers: don't call your variables names like list, L-I-S-T, because then you won't be able to use L-I-S-T, the function for creating lists, later on in your program, because you'll have overridden it. So I just call it LST. So I'm going to store the values into this list, and then I'm going to print them out. So not a very complicated program, so let's run it and see what happens. And here's our output. You can see it's displayed which ones are strings with single quotes. So single quotes and double quotes are treated pretty much the same in Python. And it doesn't record which ones you use to create the string. So to print it out as a string, it's just made a guess, and it's guessed that I use single quotes, but it doesn't really matter. And then we've got our numbers without quotes and our digit here with a quote. So remember to ask questions if you don't understand what's going on, and I'm happy to go over any of it again. And now we've got our list of values. We can refer to each of them by an index. So an index is just a counter that refers to the different elements in the list, and it's 0 indexed, which means that 0, the first one here is index 0, the next one is index 1, then index 2, index 3. So let's look at what is in list index 0, and it's the string SIX. So you'll see if I was just using normal Python like CPython, then to display the output I've had to use the print function to print the value of a variable. Because I'm using interactive Python, I don't actually have to do that. I can just put an expression or a variable name here, and it will evaluate it and display the last line of the cells. I can't do it on more than one line, but the last line it will display whatever the result is. So I can just save a bit of typing by not having to put in the word print in the parentheses. So that's told me it's SIX is the value there. The index can also count back from the end. So if the index is negative, then what it does is it looks at your list and counts back. So it goes -1 is this last one, and -2 is this second last one. So list -2 is the string ONE. Now, some things that you might want to do with a list, you might want to find out how long it is. So we can use the len function. Len is a built-in function in Python, and you can use it on many objects. In this case, the object we're going to use is LST, our list object, and it'll tell us how many elements are in the list. And remember, we counted them before, there were 7. So it's given us 7. We can also slice a small list out of our long list, and we use the index colon index notation to do that. And this will give me the all the values in another list, starting from number 2 and going all the way up to, but not including number 5. So there should be 3 elements in that list, and there they are: 4.0, 3, and 2 TWO. So this way of doing things in Python, where it gives you the starting value and it goes all the way up to, but not including the ending value, is used in a lot of places in Python, and so you need to get used to why that happens. It's got some really big advantages by doing it that way. It means that you can always tell how many things are going to be in that slice or iteration or whatever it is that you're using that way, by just subtracting the first number from the second number. So 5 minus 2 is 3, and that will tells you how many elements you're going to get. So a good way of visualizing how this slice works is to think of your list, and you think of the indexes as going in between each of the values that are there. So 0 is before the first one, and then 1 is just after the first one, and then 1 is before the second one, and 2 is just after the second one. So you can see how I've put these indexes here. The same for the negative indexes. They count back -1 all the way down to -7. So if I want to find what's in the slice 2 to 5, I just look at the values that are between 2 and 5 on my list of indexes, and there are the 3 values, 4.0, the string 3, and then the string TWO. Now, all right, so I've just got list here so that you can remember what our list looks like. That's that. And now, what does this do? I can say I want list at index 2 to equal FOUR rather than 4.0. So if I run this command here, the equals is basically means assign, means put this value into the list, and it tells you what position to do, and then tell me what the value of list now is. And if I print it out, I can see now here, rather than having the floating point number 4.0, I've got the string FOUR in capitals. Now really just going through a few things that we can do with lists, and then later on we'll get into actually using them and seeing how it was. So one thing you might want to do is delete an element out of our list. So let's use the del command. This is a keyword, so it comes up in a special color, which means it can't ever be changed, and you can never use that as a variable name. And we've deleted what was at index 4, so 0, 1, 2, 3, 4. So the TWO was what was at index 4. We deleted it, and so now if we look at our list, we don't have TWO in the list anymore. We can add a new value to the end of the list. I've gone and chosen the value 1j, which you may not know what that is, but in Python, j is the square root of -1, so this is what they call complex numbers. It's another data type. I think it's really fun to have complex numbers in a programming language. Probably not used that much, but it's fun that they're there. So let's have a look at our list after we've appended a number at the end, 1j, and there it is, 1j. Now, if I can't put just j there because it would think that was a variable name, so that's why I've had to call it 1j. Okay, now our next data type we're going to look at is a tuple. And a tuple is just like a list. Pretty much all those things that we've got with lists we can do with tuples, except a tuple is immutable, which means it can't be changed in place. So let's have a look at what that means. Let's define our tuple in the first place. So remember we put square brackets around our values to create a list. To create a tuple, you put parentheses there, and then it's just a comma separated sequence of values. And let's print our tuple. And when it prints it with parentheses so that you know it's a tuple and not a list. Just like before, we can look at the what's at index 0, and that's the string SIX. So I've got a challenge here. What is something you can do in a list that you can't do with a tuple? So you could go through all the things that we've been doing up here to lists and see which ones work and which ones don't. Okay, now I'm going to use, I've done a solution here, and I'm going to use f strings to display the solution. So I've put it here. What an f string does is an f string is your normal string. It's got double quotes around it, but it's got this f at the front, which means anytime it sees curly braces, anything inside the curly braces, it will actually evaluate, work out what it is, and display the result of what it is, rather than just show the letters that make it up. So if I run that, see this first one, TPL equals in curly brackets TPL, and so we get TPL equals, and then it evaluates what TPL is and displays that. So that's a quick way of going through all the things that we wanted to before. So let's try this. We've already tried that one. This next one, we can find out what's at index 0, we can find out what's at index 1, we can find out what's at index 6, we can even do negative indices, and see how when you're using an index you use square brackets, even whether it's a tuple or a list. You always use the square brackets there for finding something at a particular index. You don't use parentheses there. If you use parentheses, that's like calling a function. So len here is a function, and we call a function by using parentheses there, and then the value inside is the argument we're passing to the function. The length works, it returns 7, slicing works, and this time it doesn't return a sub list, it returns a sub tuple. There's extra things you can do with slicing. Actually, you can, if you leave the first number blank before the colon, it'll assume 0. So you save a keystroke by leaving that out, and see we get the 4 values here. If you leave out the second value, it'll go all the way to the end. So that's probably more useful because you don't typically know what the length of your tuple or list is, and so by leaving it blank you just know that you're going to get all the values up to the end. So that can be quite useful. You can also put in 2 colons, and so 2 colons is expecting 3 numbers. The first number is what you're going to start at. The second number, which is left out here, is the number you're going up to but not including, and the third number is how you want to step, so what interval you want to put between each of your advancements through it. So by leaving the second number blank, it's gone all the way to the end, and we're going in 2s starting from that with the index 1, so that gives us 531. So that's a fancy thing you can do with slicing. Similarly, you can do negative steps. So we've got -1 of the steps, which means it's going to count backwards. We've left the first value blank, which means it's going to start from the end. it's going to go all the way down to the value at index 1, but not including 1, and it's going to go in negative steps. So we're going to go so we're starting at this end, so it's index 6, index 6, 5, 4, 3, 2, and then doesn't include 1. So it goes all the way down to 4, and it's stepped in minus ones all the way, and you see that's what we get: 0, 1, 2, 3, 4. The next one returns a type error. Now I've just written that in, so you probably don't believe me. So let's try it out. We'll create a new cell. I don't like putting things that return errors in my notebooks, because if someone likes to run all the cells at once, then it's going to stop as soon as it gets to an error. But we can put them in now because we're working in our own local copy of it. So let's see what happens if I do tuple index 2 equals a value, and then I run that, and it says a type error, tuple object does not support item assignment. So similarly, if we had a negative index, that will give the same error. And let's try to delete an element out of our tuple, EL, and run that, and tuple object doesn't support item deletion. So that's the error that we get. Now that doesn't mean I can't make my tuple variable point to a different list. So I could construct a new tuple, and I can even give it the same name. So well, I'll give it a different name to start with. So let's go tuple2 equals, and I want everything except the second, the one at something at index 2. So it's just going to be tuple up to 2, and I can actually use the plus sign to append the two tuples together, and that's going to go from 3 onwards. And let's have a look at what's in tuple 2. 6, 5, 3, 2, 1, 0. So that's effectively the same as what you would have if you deleted this item at index 2 from tuple. And so now I could even here I could say tuple. In fact, I won't even do that. I'll do it. I'll just say that tuple equals tuple up to 2 and from 3 onwards, and that's given me a new tuple. So the point here is that TPL now has a new value, but I haven't changed the value that was sitting in TPL. So anything else that was referring to that value in TPL knows that it hasn't changed, and that's the important part in your programming. And if you have a choice between what's called a mutable or an immutable data type, this is a more advanced subject, but always try to choose the immutable, because it will reduce some really subtle bugs that you can have creep into your code that happen when you use mutable data types. That being said, most people use lists because it's easy to type square brackets, and they and the fact you can do things with them, just you can do more things with them, means people like to use them. But yeah, if you can get the discipline of using tuples wherever possible and lists only where you need them, then you're going to be better off. All right. Now you can convert between the two. And the way you do that is you use a function with the name of the data type. So this is a typical way in Python for changing data types, converting from one data type to another, is just use the name of the data type and pass in the object that you're changing the data type of. So we can pass our tuple into the list function, and it will return a list. And I'm going to call my list from tuple. So let's have a look at it. And that's got the 6 elements, and it's now in square brackets because it's a list, and then I can convert that back to a tuple just by using the tuple function, and you can see now it's got parentheses. Now I haven't saved that anywhere, so it's really lost, but if I wanted to, I could have saved that into a variable. So let's have a look at some Python programming. Presuming this is early days in your Python programming career, so I'm sure you're dying to get into actually doing some programming, and we're going to look at the if statement. So if is a way of changing the way that the code works. Up until now, every line in a cell, it's just run them in order as we've gone through the cell. But now we're going to make decisions as we go through and change which code gets run based on some sort of condition. And we use the if statement to say what we want to do if some condition is true, and we can use an else statement to say what to do if it was false. So I want to roll a die, and using a random number generator, and so I want a number between 1 and 6, and I'm going to use the randint function that's in a library called random. Now because it's not a built-in function, I have to import that library first. It's a standard library, I don't need to install it, but I can just import it, and then I can run this function randint, and it will return a value between 1 and 6. Remember how I told you before, well, I didn't, it will go up to but not including. This is one of the very few functions that goes up to and including the final value, and they tried to get rid of it out of the Python language, but so many people were using it, they decided to leave it there. So this is randint, and let's run the code and see what it does. So it returned you rolled 1, so the value in die roll is 1, and it is an odd number. So how did it work out it's an odd number? Well, it did this little, looked at this expression here, which is a conditional expression. It took the value that's stored in our variable die roll, and then it divided it by 2, and then looked at the remainder. So that's what that percentage sign in means. It's the modulo operator. It divides and takes the remainder after integer division. So we rolled 1 divided by 2, that is 0, remainder 1, and so I looked at the 1 and checked if that was equal to 0. Does 1 equal 0? No, it doesn't, so it didn't run this code, but we've got an else statement, which means what would you do if it was false, and that's what it does. It prints you rolled a 1, which is an odd number. Now the other thing here that you'll see with Python is the way it designates code blocks. So we've got an if statement and then a block of code that it's going to run if it's true. Then we've got an else statement and then a block of code that it's going to run if it's false. Now in other languages they might have curly braces around all the code in the code block, but in Python you're generally the code block is designated by its indentation, and this is designed to make it easier to read. It's not cluttered up by special characters all over the place, so it's clear to read, and you can just see that. So there's only one statement here. If we had several statements, they should all have been indented by 4 spaces, and then the else being not indented means that's the end of the code block and the start of a new code block. So we'll see later on where there's more lines in there. Now the traditional number of indents is 4, so I'd suggest using 4. If you're running your own copy of Colab, I think I've set my Colab up to do 4 to make it consistent with the Python standard, but the normal Google Colab I think uses 2 spaces for indentation. Oh, here we go. I talk about indentation here. So you can go to Tools, Settings, Editor to change what indentation you want. Okay, so I hope you understood that little bit of code. And so we've set a challenge for you here. Roll 2 dice and report whether the first die rolls a greater number than the second. Okay. So let's, I'm going to have D1 is going to be my first die, and I may as well just use the code that the AI has generated for me, and D2 is the second. And then I'm going to do an if statement. If D1 is greater than D2, so that's my condition, that's the test that I'm doing. So I do a colon, say now I want to start a new code block. You don't, that's just to tell Python that you're expecting a code block to come. It doesn't, you don't always need a colon before a code block, but most times you will. If you've got a colon, it means then there will be a code block following. The first die is greater than the second. Yeah, AI got that right for me, so that's okay. Report whether the first die roll is greater than the second. Okay. Else, what do you think AI is going to say for this one? For less than or equal? Yep, well, that's right. So let's go with that. First die 3 is less than or equal to second die 6. Well, that's right. So the code is right. Let's run it again. First die 6 is greater than second die 5. First die 5 is less than or equal to second die 5. Very good. So that's the code. Now, we could have done that using tuples. So here it is. We're creating our tuple and storing it all into one variable, dice roll. And when we print it out, it says you rolled this, and then it says whether the first roll is greater than or less than the second. And I've even got 3 tests here. It's greater than, less than, or if it's not greater than or less than, it must be equal. So they are both equal. So let's try running this a few times and see how it looks. So things to note. There's our tuple getting displayed by our f string here. That's what's in the value dice roll. And see how I've got several print statements, but they all print on the same line. And that's because after this print statement, I put in this extra parameter and said, so I put a comma and I said end equals a space rather than a new line. So it's just put a space in there. In fact, that one there is the space because I put a space here as well, which I probably didn't need. So let's get rid of that space and run it again. And so now there's only one space in between the full stop and the first letter of the next sentence. You rolled 3, 2. First roll is greater than the second roll. 6, 6. They are both equal. Okay. Challenge 3. For an element of tuple, say whether string int other. Okay, check an element is a string by using type equals string or is instance string. So type is used for an exact match of class and is instance true if class or subclass. Okay. So let's see, I've got I'll have an index, let's say index 3, and I want to check if the type of the value at tuple at index is a string, then I'm going to print it's a string. This is doing all the work for me. How could you possibly get it wrong? Okay. Now, see how it's wanting to put another line at the same indentation, and that's the code block. But we're going to not indent here, so I'm going to shift tab to get rid of the tab and put an else in there, else if type is an int, then I'm going to print it's an int, else I'm going to print it's something else. Okay, well that all looks good. So type of, we should really print out what is at type 3 is a string. We should say what it is really, shouldn't we? So let's print it as well. So 3 is the value TWO, and it is a string. Okay, so let's try 1 is an int, and it's just the digit 5. Okay, and let's try 0. Okay, so yeah, it's a little bit cumbersome having to go through each of these index values and find out what they all are. So Python's got a thing called a loop, where you can easily loop through all the values in one of our lists or tuples, and it uses what's called a for loop. So it says for, and then we just create a new variable here, a in tuple, and it'll do all of this code that's indented, and it'll do it each time with a different value of a. But and so you notice how I've got all of that in one code block, but within that code block I've got these other code blocks which have got double indentation. So that's inside that code block, it's another little code block. So that's how you nest your code blocks, by just doubly indenting. So let's run the solution and see what it comes up. So I've got the type as a string for 6, int 5, string 3, 2, 1, 0. And I haven't got any examples of other here. So let's create a new tuple, and we'll put our 1j on the end. And we've also got 4 in there. So our floating point number, that's not an integer, it's a floating point number, and so it said it's another, and it actually tells us what the class is. And similarly 1j is a complex. Okay, well let's have a look at other loops that you can have. So we've got the for loop. Sometimes we want to repeat the same code block many times, so we use loops. Yep, that's right. So 3, 2, 1. So that's looped through all the values in that tuple. You can even loop through all the letters in a word. Let's give that a go. For letter in A, B, C, D, E, F, print letter. And if it sees something like that and you ask to iterate over a string, it will go letter by letter, and that's what we get there. Okay, so another sort of loop is the while loop. So while is like an if, so it's got a condition in there, like an if statement, but it'll do it, and then it'll do it again, and it'll check the condition again, and if the condition is still true, it'll keep doing it while that condition is true. So it's pretty important when you've got a while loop that there's something inside that loop that will change that condition, so eventually it'll go false, because otherwise you'll just have an infinite loop. So in this case, we've got this line here, counter plus equals 1. So we'll keep incrementing counter, and eventually it's going to be greater than or equal to 10, in which case our loop is going to stop. So what are we doing? We're rolling the dice 10 times, and each time we're checking whether they're which one's greater. So there's our 10 dice rolls. we rolled 3 5 1 1 1 6 5 1, so we've got an equals, we've got a first less than, we've got a first greater than. So that was a pretty powerful way of getting lots of code to be run in just a few lines of typing. Okay, challenge 4. Write a program which prints every number from 0 to 20 as digits and its name in words, as well as whether it is even or odd. Okay, and we've got all our numbers in a tuple here, so let's run that. Okay, and so now we know that it's there. So we can, we want to have a counter, so let's have our value I equals 0, that's the first one, while I is less than length of numbers, that'll work. If it's I% to, what do we have to say, whether it's even or odd? So it's using this modulo to work out if the remainder is 0, then it's even. If it's otherwise, it's odd, and then it's going to print it out. It's going to print out the value of I. It's going to look up our numbers. Well, it's done all the work for us, and it's going to say whether it's even or odd. So when you use the AI like this, try to understand what it's actually doing. Aha! An AI made a mistake. So I have to interrupt it here. It forgot to add in I plus equals 1. So I have to increment I by 1 each time, and there we go. That's the thing that I said was so important to make sure you did in a while loop, and the AI got it, didn't do it. Even odd, even odd, even odd. All the results look good here. You'll see here it's used a bit of formatting in our F string so that it's made all of these 15 characters wide, so that then our columns line up better. And even our digits, it's made them 3 characters wide and right aligned by putting these colon in here and a column width. Okay, any questions on that bit of code? All right, so let's have a look at a different way of doing that. The reason I used a while loop here is because I wanted a value I to convert to a string, so 0 to zero. So I couldn't just use the for value in numbers, because then I just have the strings, but I wouldn't have the integer number that it was equivalent to. But there's a built-in function in Python called enumerate that will give me the index value as well as, well, it'll give me 2 values. It'll give me an index and a value out of a tuple or a list. So it stores in our for loop here, we can put 2 variable names here, and they'll each get assigned each way through the loop. The first one will be an index if we're using enumerate, and the second one will be the value in our list or tuple. And so there's the result, and you can see that it's used, AI used exactly the same print function that I used in my solution. So it was looking ahead and decided to use the same one as mine. Not sure what I think about that. Okay. So, so the problem with this code, so we're trying to convert numbers to their names in words, is it doesn't scale well. So, like if we, to have 21 numbers that we've got there, we had a numbers list that was 21 values long. Now, if we wanted to have 100 numbers in there from 0 to 99, then we'd have to have a tuple or a list that was 100 values long. So we're not, as it scales, it's just going to get incredibly big. So we want to do something, look at the patterns, and maybe we can store the tens somewhere else. Like here, we store them in a separate tuple, and then at any time we can use a combination of the two tuples to work out what the name of the number is in words. So here we're going to convert the number 30 into its name. So to do that, we've got our tuple here. We've got the index, or a value I of 30, and then to get the index we have to do an integer division of 10 and then subtract 2. It's a bit complicated, but it'll give us the right answer. So what's another way of doing it? Another way is using this dict data type, which stands for dictionary. So it allows us to have all our values, but also we can specify the index. So we've got here our values 20, 30, 40, but we've also can put in front of them the index that we want. So remember, I is 30, and so to look at I and tens of I, we get 30 equals THIRTY. So your keys, I've got here an example with keys being integers, but your keys can be anything that, in fact, it has to be an immutable data type. So strings are good, integers are good. They're the most common ones you'll ever see. So, for example, here's the phonetic alphabet. If we want to convert the word Python into its phonetics, then it would we can use this dictionary and look up each letter and find out what its phonetic name is. So, for example, Python will be Papa, Yankee, Tango, Hotel, Oscar, November. Okay, write a Python script to write a number in words for any number between 0 and 99. Consider the following conditions. Number is less than or equal to 20. Number is greater than 20 and divisible by 10. Number is greater than 20 and not divisible by 10. All right, so let's come up with a number. I equals random dot rand int 0 to 99, print I equals I. So that'll just give us a random number. All right, so we've got our random number. Here's an example, I equals 58. And we're going to consider the following conditions. The number is less than 20. All right, so let's go. If I is less than 20, and less than or equal to. So even though in Unicode you've got less than or equal to like that, in Python, if you wanted to write less than or equal, you have to write it as a less than sign and then an equals sign. Then we can print numbers I, else. Okay, let's do that, and I'll just put else print too hard for now, and let's just run that, and we'll put that all on one line, and equals. Okay, so I'll just keep running it till we get one that's less than 20. 8, there we go. 8 is less than 20, so that works. So a second test is going to be it's greater than 20 and divisible by 10. So I've got an else, so I already know that it's greater than 20, but I want to check if it's divisible by 10. So I can do the modulo, check it's equal to 0, and then print tens of I. Yep, that looks good. And I need to put a colon. Wow, how did AI forget to put the colon in? So 10 is 10, but that's come up through this bit here. 90, so that worked as well. So we've used numbers, we've used tens. Otherwise, we have to work it out. with the numbers and a 10. All right, so otherwise we are going to say print. Oh yeah, so it's looking at my answer. It's using even the same variable names. So, well, it's all there. May as well use it. Value of the ones is going to be I divided by 10 and take the remainder. So if it was 91, then that's going to give you 1. And then the value of the tens is going to be take our original number and subtract the remainder, and that would give you what it was. So, and we can print the tens and then a hyphen and then the numbers, and we don't need, I've got to press tab, and yep, there we go. I don't need that. And there we go, 78 equals 78, 50, 83, 50, 13, 18, they all look good, 45, and it's putting the hyphen in there as well. So if you want to have some fun, you can try extending the range up to thousands, see if you can put in some more else statements and get your get the bigger numbers. I used to take this up to millions and gazillions, and now I've put them in a for loop for everything up to 99, and you can see all the values there. So that was fun. We're getting through it faster now that AI is guessing answers for us. If you've got any questions, feel free to, well, I'm going to sign off soon, so that'll be too late to ask them to me, but you can put them in the chat here and in Slack, and someone can answer you, or if I see it, I'll try to answer it during the week. In a couple of weeks' time, I'm going to look at object-oriented programming, so that'll be interesting. Python's got a lot of object-oriented programming facility. It lets you write programs either object-oriented or not. So object-oriented, while Java, for example, everything's got to be object-oriented. It does keep your code, when you're working on big projects, object-oriented programming is very good at segmenting the code into different areas and keeping your code clean and easily maintainable. So I recommend it for big projects. For smaller projects, you don't need it so much. You can actually just make it a bit more confusing. All right, well, I hope you learned something from that, and if you like it, click on the like, and if you want to be notified when I'm putting more videos up, then subscribe to my channel. Thank you.